So when we deal with motions that have constant accelerations, the equation that we often use in physics is x equals x sub naught plus v sub naught t plus 1/2 at squared. When we have an object that's moving from point A to point B at a constant acceleration and we're trying to find x, then we use the equation above. So what is x? X is final positions. X sub naught is the starting positions. V sub naught is the starting velocity. T stands for time. And A stands for the accelerations. When we combine the result of the average velocity and general formulas for positions, we will be able to get the equation above. And let me show you how you can do that. If you take the definition of average velocity is the starting velocity plus the final velocity divided by 2. And you take the definition of accelerations equal to final velocity minus starting velocity divided by t. And if you multiply t from both sides, then the t from the left side disappear. If you plus starting v sub naught on both sides, then the v sub naught on the left side will disappear. And what you will end up is v is equal to at plus v sub naught. When we combine those two, we get average velocity equal v sub naught plus v sub naught plus at divided by 2. And then become average velocity equal v sub naught plus at over 2. So now that we have the average velocity, we can move that up a little bit. Now the general formula for positions. So the definitions of average velocity again is x minus x sub naught over t. And if we multiply both sides by t, then the t of the left side will disappear. When we plus x sub naught on both sides, then x sub naught from the left side will disappear. And what we have left is positions equal to average velocity multiplied by time plus starting positions. So what we can do now is if you take the average velocity from the left side and put it into the equation of the right side, what you have is x equal to v sub naught plus at divided by 2 multiplied by the t from above, and then plus x sub naught. Now if I clean up the algebra a little bit, it will look like this: v sub naught t plus at squared 2 plus x sub naught. And then of course if I arrange the x sub naught to the front, they become like this equation that we often use in solving 1D kinematics when we have constant accelerations.